job shout-outs. On the Ansible side, they're hiring for pretty much everything. Front-end developers, solutions architects, contract specialists.
You do not want to hire me as a front-end developer.
Everything and anything in between. It's primarily a Python shop, but the Tower piece is very JavaScript heavy, and it is a Django backend. So the kind of skill sets they're looking for. And then I don't know if anybody else has any job announcements.
This is typically how this group works. We'll try again at the end, maybe.
When people are a little bit more.
All right, so the talk's going to be about lessons learned at NASA using Ansible. I've been an employee with Ansible as of yesterday. Before that, I was with NASA with a subcontractor. The overall effort was the migration of NASA's private and public-facing web applications to the cloud, which up until my last day, it was exclusively on AWS. And with that, there were several challenges, one of which sort of started being tackled when I came on board in January, and that was to have some kind of automation in place with hundreds of servers and resources from the cloud in place. Managing things manually or dealing with snowflakes wasn't really an ideal situation, and that's kind of what it was day one. I'm in DC. I just was in the Army for a little bit. Prior to Ansible, prior to NASA, I was a developer at a couple different startups, primarily with HTML5 and JavaScript stacks. Then I led much of the effort for DevOps implementation stuff, if you will. At NASA, the name of the contract is West Prime. You can Google that at your convenience if you care to find out about dollar amounts and the government officials behind that. And again, Ansible as of yesterday. So we're going to discuss things in kind of a sequential format based on that initial poll that I took. It looks like a lot of people are relatively new to Ansible and what it does. So I'll refrain from going too deep level to where only Ansible power users, if you will, would grasp it, and try to make it relevant for everyone. So if you are thinking about trying out Ansible, or you're currently in the evaluation process, you kind of learn from the gotchas we discovered as we deployed it. So I broke it down into 6 major categories. First one being access control. Being a government environment, we fell under a lot of compliance issues. The big one being FedRAMP, right, where you have many controls to include keeping detailed logs of everything's happening, and many others. The next was speed. Ansible, out of the box, assumes very little. So it gives you what you need for it to work for pretty much any environment, as long as you have SSH and Python in your environment, which is the standard for most Linux distros. It works, but there are some tuning things you can do if you're running with more modern stacks, the latest distro releases of Red Hat or Ubuntu, for example. The next one is the directory structure and style guide, things that we found more sustainable and nice to look at and less confusing for people as they look through the playbooks. And our movement from having a very disparate bastion type of access mechanism for Ansible to not having that. And I'll elaborate a bit more on that when we get to it. And then the next one was, with Ansible it being open source, you can obviously hack away, add what you want, take away what you want. But when you do upgrades to Ansible to its core base, whenever there's been a patch or anything, you'll lose your modifications if you've made those directly to where it was installed. So we'll talk about how to upgrade Ansible without losing those modifications. And then lastly, the AWS tagging mechanism we found most effective for leveraging Ansible and the dynamic inventory features it provides. All right, so access control. When we're using core only, Ansible core meaning just a command line version of Ansible that you can get for free, it'll always be free. we had a particular setup in place, right? We have key-based SSH access into our servers, right? It's a pretty standard thing. Ansible would then only work on servers people had access to. So if a group of developers, they would generally have access to their development environments and their staging environments. If they wanted to use Ansible, they would be able to go into our Bastion/jump host, execute playbooks, but even if they tried touching production because their keys were not on those machines, they wouldn't be able to touch them. So activity was limited in that manner. In general, ops and security, of course, has access to everything. There was no limitation there. The Bastion access point was sort of the default standard, limiting the surface of attack. But at the same time, it made things a little bit inconvenient. We'll get into that in a little bit. People could also run locally. Again, talking about compliance, you can probably gets a little bit sticky, right? If people are running Ansible playbooks from their laptops, even if it's run through the Bastion, you lose a lot of visibility into the history of what's going on. And for scheduling, there was a lot of cron, probably too much, and that resulted in some conflicts for certain issues where, for example, with like apt-gem repositories, it would lock the process, and then if you had something else being launched at the same time, there would be conflicts. So, as I've been alluding to, there is certainly problems with just using core only in our particular environment. All right, compliance was painful. Again, logging, we were essentially piping out standard error to a data text file, but that became pretty unwieldy, and it's too easily touchable, right? Because there were text files, anybody who had access to that particular directory could simply remove them or simply choose not to create a logged text file. The other one was trust issues. If a development team decided to launch a playbook, that's great, but at the same time they would also be able to create their own playbooks and run it in their staging and development environments without necessarily having gone through any formal oversight, which was leading to more snowflakes and occasional things breaking. And the other piece is that management really couldn't help. When you're talking about command line stuff, especially in the government space, program managers, the management types in general, really, for the most part, aren't technical people. So there really wasn't a way to ask them to help with a deployment, even when it was just a simple command line thing. One, they didn't necessarily have SSH access, and two, they probably didn't have the technical expertise. And cron, as I talked about earlier, it's a pretty shitty scheduler when you're dealing with many different things running at different times, sometimes overlapping. The solution for us was Ansible Tower. I might text not to be too salesy about this, but for NASA's particular use case, it was something that made absolute sense. The first piece of that was the role-based access control that comes native with Tower. It allowed delegation, multi-tenancy in sections of organizations, teams, and users, which is great because then we could really fine-tune who could do what and when, and it eliminated that whole piece of developers being able to write their own playbooks, execute it on a given environment, and not really having any accountability for that. The built-in logging is great. It provides very detailed information as to who launched the playbook, what the playbook actually was, when it was launched, and its level of success or failure, and in a very beautiful graphical user interface. And it's also non-techie friendly, right? So it's just a 443 front end. People can log in just as they would to their email accounts or anything else, and a manager with no technical experience could go in, click a rocket ship icon, and make a deployment happen, or any other given Ansible task. And it also provided a very nice scheduler, certainly better than cron, and it provided the queuing mechanism necessary, so whenever there were conflicting jobs, it would run them one at a time, so it eliminated the process conflicts entirely. All right, the next part is speed. Like I said earlier, Ansible is pretty quick already, but there was something we discovered when you're dealing with hundreds, if not thousands, of nodes. What it comes with out of the box can be a bit slower. So there was two things. There was a 2x performance increase with pipelining that we discovered, and that involves disabling required TTY in sudoers files, and that can be in your main sudoers files or in any sudoers D. You just append it to the end of your defaults, just with the exclamation point required TTY. We have a particular playbook that bootstraps machines with our users, so that includes the operations team, the security team, and in that it also modifies the sudoers file. Now, this is important when you have an Ansible playbook that's leveraging sudo. If you have a playbook not doing sudo, then you'll be fine running something through pipeline. Now, Ansible config, there's something locally stored in the etc Ansible directory in root as your default config. But you can also include a config within your playbook where you can make it run by the old mechanism to set up the new, and then subsequent playbooks would leverage pipeline. So this is an example of what the snippet within Ansible config. It's pretty simple. It comes by default commented out. We simply remove the hash and change it to true, and you've effectively enabled pipeline. And then here's a sample Jinja 2 template for disabling required TTY. You see, it's just simply making the defaults with required TTY disabled. And as far as control machine, I found that it was easier with Debian family machines, in particular Ubuntu. And that's because Red Hat machines prior to 7 had some control persist issues. So pipelining, while improving the performance, wasn't necessarily to the 2x extent. It was maybe a 10% increase. I believe 6.4 for Red Hat and above has now been patched, but that's been really recent, and I'm not 100% sure on that. But I know Ubuntu had no issues with that. Okay, the next part is style and uniformity. As you start having many playbooks in the tens, maybe hundreds, maybe thousands, as is the case for a few clients, you run into a hellish scenario in that no two developers or ops people write a playbook the same way without a standard already in place. So YAML, as those already familiar with YAML, it's not a very strict syntax language, right? You can have 4 spaces, you can have 5 spaces, and it takes it in all the same. There's no particular self-linting mechanism there. It'll run regardless of how you write it, with some rules. So the style guide we put into place was borrowed from EDX. They open sourced it on their GitHub repo, and we added a couple more pieces to it. If you sent a text message to the poll at the beginning of the slides, you should have received a link that takes you to that on GitHub. It covers everything from formatting to syntax, and following that mechanism makes it very easy for anybody to come in to your Ansible playbook repository, if you will, and see what's going on, know where everything is, and how everything works. The next piece is architecture. We kind of talked about this earlier. We had a system involving bastion hosts, which would then connect to different places in the environment. And so with core only, we had Ansible installed on various bastions. The NAS environment has several VPCs, and to run Ansible on them, you would have to go through the bastion associated with a particular VPC. Again, not efficient, very snowflake prone, and really not pretty. It was a pain in the ass in that simple things like just patching required SSHing multiple times into different servers, helping developers who aren't sysadmins connect through the bastions really sucked. was really inefficient. And again, the whole snowflake issue, which is a very bad thing for compliance.
How did that create more snowflakes, out of curiosity?
So from a directory perspective, so there'd be some playbooks in one server and not necessarily others, and there'd be, if they didn't update them from the Git server, they might be at a different state than others. So even they might think they're running the most recent playbook, but not necessarily, unless they were prudent, which isn't always the case. And also from the aspect of them doing any modifications locally with Ansible itself. So the simple solution for us was sort of a facelift to the environment. We created a single management VPC that then had peering enabled to the other VPCs. That's a feature provided by AWS, which really eliminates the need to set up a more complex open VPN endpoint type of architecture. With peering, that was acceptable to NASA because the flow of traffic is pretty controlled. So just because the management VPC could connect to half a dozen others, those VPCs could not communicate with each other. So that management VPC served as a home for Ansible Tower, our Ansible core use, and for all the other tools that we use in our environment, like our SIM and our security tools as well. We had Tower connect through private IP addresses at this point. This resulted in a pretty significant performance increase as well, since it really didn't have to go out to the internet to figure out where to go to. They're just communicating directly on the same network. Next part is upgrading and custom hacks. As I said earlier, if you make any modifications to Ansible's code in your install, when you go to update it, be it through source or apt or yum or pip, you'll override your changes, and remembering to update that can be a bit painful, if not just tedious. So we made a few relatively basic mods. One of them is to provide more detailed RAM in the Ansible facts, as well as a list of packages installed through apt and yum. And that was the list of apt and yum pieces were as a result of a compliance need from the NASA customer where they wanted to be able to see that. So what we did is added that fact, it came out, we sent those facts to S3, which were then pulled in by our cloud management platform, which then had a GUI interface for the government types to look and see everything that was installed without us having to manually go in and parse that out for them. The modifications that I made are also available on GitHub. You should be able to see them. If you want to use them, feel free to. It should work on, it's been tested on Red Hat 6.4, 6.5, and Ubuntu 12 and up. So the solution there was simply an Ansible playbook to reapply the modifications. So when we would upgrade Ansible, we would just simply run a playbook that would then go in, change the files that we changed. In my case, the facts.py file, and it was good to go. It was much easier than trying to do things with typical command line using move or copy. And the last piece is AWS tagging. So within Ansible, there's a notion of dynamic inventory. It's a simple script that calls out using Boto and pulls in a list of everything that's in your AWS environment and groups it rather intelligently. It'll group it by security group, whether it's an EC2 or RDS resource. It'll group it by region. It provides a lot of things out of the box for you in that fashion. And it also groups by tags. And being that it groups by tags, we were able to leverage that pretty effectively to target very specific resources without really having to worry about maintaining a manual host file, which is the case for many people. They'll make a host file, and it's an INI formatted file where they list IP addresses, URLs. That can get a bit tedious to maintain. So our basic tagging scheme consisted of having a tag for the operating environment, whether it's the development, staging, or production environment. A naming scheme that followed a format similar to this, where we have the name, some kind of canonical name, its function, in this case a web app, its quantity, so at the very least one, its environment again as prod, and then the VPC where it was located, so in this case, management. And then we also had a tag for Windows to identify those as well. Now, what that enables is something pretty interesting. So if you look at this first declaration of hosts, within Ansible playbook, host is you define what to target there, right? So wildcards work the way you would expect them to. So if we wanted to target every web app in dev, we could simply do this, and the script would take care of the rest and target all of that automatically. Same thing if we wanted to tag everything in production in the management VPC, we could follow the same wildcard scheme. The dynamic inventory script does all the heavy lifting for you, and it works beautifully. And that was it. Cool. So, any questions, guys?
Given different tools between Ansible and Salt, why Ansible?
Sure. So that was something probably around the February or March timeframe. We evaluated 4 tools. We evaluated Ansible, Puppet, Chef, and SaltStack. We had a demo day. We had all of the vendors come in, do an hour, hour and a half long presentations on their enterprise service. That was something we were interested in particular. And we had a list of about, I want to say, 30 to 40-ish criteria that we rated on a 1 to 5 scale. Everything from how well it works with Docker, to how easy it is to pick up, to the speed of deployment once we procured it. And we ran through them, and we inevitably chose Ansible. And I can cover a few of the big things for us. One of them was Ansible's native use of SSH, where with Chef, it defaults to 443. With Puppet, I believe they have their own custom port, like 4,000 something, I believe. And rather than go through the bureaucratic hurdles of having to approve additional holes in our security groups, say we already have SSH access, so with Ansible, we don't need to modify our security posture at all. That was a big one for us. The other one was the ease of learning. We had myself included, and a couple of the other guys that were doing ops. We're playing around with the open source versions of the tools, and the 3 of us, pretty much within a day, we were already writing Ansible playbooks and using the open source version. Whereas with the other tools, we actually couldn't really even evaluate them in terms of their agent architecture, because to do so, we would have had to get approval from the change control board to deploy the agents, and then subsequently to open up the security groups to allow them to communicate over those ports. And that obviously presented some headaches as well. And then just our general research into the whole automation community. It seemed a lot of Chef and Puppet implementations were halfway done, never really fully done, just because of that whole agent architecture that presents a significant amount of complexity. And then lastly, the other thing was the language issue. With Puppet, you have their own version of Ruby. With Chef, you have pure Ruby. And with Ansible, it's just YAML syntax. So an ops guy who's never really developed in the classic sense in his life can write playbooks without having to learn a programming language. So that presents significant cost benefit from a hiring perspective. You don't have to hire ops people who know how to code Ruby. You can just hire ops people, and they should be able to figure out YAML pretty easily. Yes?
Where do you store your Ansible scripts and playbooks? Are they in their own separate DevOps repository?
Yeah, we had a local Git server, and we'd store them. It depends. So certain applications within NASA, be it compliance issues or other things, we kept the playbooks in with the apps repository. But for other more OPSI general tools, say patching the servers or adding, removing users, just keep that within the same repository.
you done any work with Ansible pull? I want to be able to have AWS instance, spawn up based on load and go out and configure itself by pulling stuff in rather than sort of pushing.
So with pull, we didn't use that. As you know, Chris, at NASA, they didn't actually leverage any auto scaling. Had they used auto scaling, the way we would have gone is the callback feature. The callback feature is present within Tower as a fully discoverable API, and callback method is just a simple GET request. It's a RESTful API, and you can plug that into the user data of your auto scaling configuration, and as your instances come up, you can use Tower to bootstrap them.
Cool. Okay.
Any other questions, guys? One thing I was going to add, the rating criteria, I have a sanitized version that I'm allowed to distribute. I'll post that on the GitHub as well, if you'd like to take a look at it, or anybody else for that matter.
This is all in your GitHub, correct?
Yes.
Okay. Did NASA open source any of their playbooks or any pieces or?
So, one of the
Jerk.
one of the coolest playbooks is our security hardening playbook, which really hardens our instances pretty well. Probably a bit too much. It's probably on par with what a lot of banks do in terms of hardening their systems. I'm actually working with the security team at the present to sanitize it a bit, remove any proprietary stuff, and then open sourcing that. And that'll probably be available within the next week and a half or so, and I'll put that on GitHub as well.
Interesting.
Is that just for Unix based, or does it include Windows as well?
That is for Linux only.
Okay.
Can you talk about the Windows stuff? Because I know that was a big push for you guys.
Yeah, so the Windows stuff, Windows management within Ansible is relatively new. It's still technically in beta, but still very much able to be used in production environments. It just doesn't have as many modules as the Linux counterpart at the moment. And it essentially works over remote PowerShell and executes PowerShell on the node instead of the Ansible way where it connects over SSH and then executes Python on the remote machines. And honestly, we didn't get to the Windows piece of it, so I can't speak to it in our particular use case, but I know it's there and available for organizations that have PowerShell competency.
Yes.
Just as a follow-up, is there a way that you can write operating system agnostic playbooks and scripts and have to figure out whether it's running the PowerShell version of it?
Right, so that actually is part of the reason we added a Windows tag to our environment. For Windows, because it doesn't function the same way SSH does in terms of keyless SSH-like access. You need either a certificate or you need to pass in your username and password to connect over remote PowerShell. That presents a little bit of challenge when you're talking about any kind of Linux versus Windows and running that intelligently. So the way that was planned was to have playbooks running exclusively for Linux without any kind of Windows intelligence in them because of that nuance, and then a repository for Windows stuff.
So they're just separated because of how different the connection is.
Right, exactly. Yes.
So I'm a developer with your group, okay? I want to launch the most recent instance of my web app or whatever it is that I'm doing. How does that process work? And specifically, I mean, so it sounds like you have a similar problem that I have where security is of prime concern because it's government, they have to do all of their own steps, and then you might get access to a machine. Or, if that's not the case, if you're launching a machine on the fly, how are you separating, and I know technically it's possible, but also in terms of permissions or Git repositories, in what sequence of events does, for instance, the machine launch up, all of the standard packages are installed, then I'm guessing some sort of security thing, and then the developer gets to put their instance on only after everything else has already been completed.
So that part we actually did a pretty good job of speeding up. I'll be open sourcing this too. I'm almost done sanitizing. That one should actually be available this week. It's an Ansible playbook, and the way we ran it, we had a series of medium-sized instances running just during business hours, and every day at 7 a.m. it would apply the latest and greatest standard, whatever that may be. So we use Tower for that. It would go in, make sure the users that are supposed to be there are there. It would run updates for the package repositories. And then the playbook that's doing all of this was able to be modified by ops and security. So if they needed to make a change, they could do so. And then at the same time, it created an AMI of that every day at 7 a.m. So then when people needed a machine, we would just look in the list of AMIs for, say, Ubuntu 14 created at 7 a.m. with today's date in the same column.
So that would work every day.
Yes.
So then you're okay. So then you have a base, basically a Phoenix server at that point. Sorry, a immutable server at that point. How do developers have access? So in your VPC, I guess developers would have access to a separate instance set of playbooks that they could then say, "Hey, go install my app on," or would those automatically be run? And if you're sitting behind load balancers, are you then switching out the new and the old somehow via another set? And does that run after the users have already installed their app, etc.?
Sure. So
Sorry.
there's a few things there.
Yes.
And
Couple.
Let me know if I miss particular topics. All right. So I'll start from reverse because that's what I remember. The load balancer question. So in our particular use case, all the apps had load balancers. We were either leveraging load balancers because of the IPv6 piece of it, or using them for CMS type apps, so like Drupal or WordPress, to where the content itself is stored on the database, and then the static files were stored underneath on a clustered file system. And so updates there from the developer side, they would have access to their repository, and when they needed to make a push to development stage, they have access to it. But for production, they would let the operations team know, and then that would be deployed, and then everybody crosses their fingers and hopes that nothing went wrong in that situation.
But are they deploying by spinning up a whole new load balanced group, or
No,
by
so-
subbing out the old one?
Right. So the environment at NASA is not immutable. That was on the is on the roadmap. So all the application servers persisted unless they broke and then they were replaced, obviously. So any kind of updates happened on servers that already existed.
I see. Okay.
Does that make sense?
Yep.
Was there
I forgot my other one, so don't even worry about it.
Yes.
On the subject of like people that auto updating, what's your strategy for like updating packages and stuff to make sure that you don't just break boxes? Like, do you blindly update or do you test updates on like a test server first?
Right. So at NASA, what we would do is update development and staging environments 1 week, just a blanket update, and then we let it sit for a couple weeks, and then you generally application owners at that point, usually within a few hours, would let us know if something went wrong, and if that was the case, we would address the issue and go from there. But generally, that didn't happen, and then 2 weeks after patching those, we would do it on production.
And like, what form did that take? Did that be like you version bump something in your scripts, or?
So for us, it was really simple. It was just the equivalent of doing yum update alt and apt-get dist upgrade on machines. Cool.
One last.
Yes.
So let's say you burn this AMI that you have that's going to be used for the next day. That is going to be the new target for any one of these new servers that's being... so the servers are staying stationary. They already exist. Okay. So if you burn a new AMI, how does that then get to replace a previous one?
It doesn't replace it. It's for new stuff. So the nature of the contract was for the migration of applications, and it wasn't just a one-time thing. It's constant.
Okay.
So while the bulk of the applications currently being hosted on AWS happened in those first few months, it's perpetual. Like there's new apps. NASA essentially resells it to itself to other centers, and they're like, "Hey, Johnson Space Center, bring your apps to AWS."
Okay. Cool.
Tower seems to be a critical success. Can you see doing this successfully without Tower in a, especially pointy-haired boss, government, enterprise-y type of environment, or is Tower really, it's got the eye candy, it's got the automation, it's got the logging in RBAC that PHPs really need?
So I think it is a perfect solution if you don't have the time and resources to make your own. Give an example. I went to a meetup the other day where a competing tool, they did a presentation, and they essentially recreated Tower for that tool, but internally in-house, and it took about 6 months worth of development to get what they needed from a compliance perspective and an RBAC perspective and all that I can do. So I think the price point at Tower, if you're already a pretty large team, is quite minimal for the benefit it returns. All right. Thanks, guys.
All right. Based on what you guys want to do, we could do a couple of lightning talks. I think we've got at least... No? All right, he's shaking his head.
Talk about.
Does anyone have anything else to talk about? We can do it. All right. We've got at least one. Anybody else? All right, one, and then we leave early. That's about it. Walk back through the rain a couple minutes earlier.
Hey, do you have the thing I could give them?
Yeah.
You got yours? You got it.
Oh, okay. BGA? Okay, cool.
All right, well, I didn't make all these slides just for tonight, but I changed the title at the bottom, so that's all. My name's Kelsey Jordahl. I'm here visiting from out of town. So I just happen to be teaching a class in town this week. I work for Enthought. We're scientific software developers, consulting. We have a product, a Python distribution called Canopy. That's an application and scientific Python distribution, and we do training classes. So I'm here teaching an open training class for the week, and I'm stopping by a couple of meetups while I'm here. So what I'd like to talk about tonight is a project called GeoPandas. So I'm interested in working with geographic data in Python. So how many people work with GIS or geographic data in any way? So a few people. With ArcGIS, proprietary tools. Anybody use the open source stack for GIS software? A couple. Okay, so most of you who have used it have used ArcGIS and similar things. All right, so this is an all open source approach to doing processing of geographic data. And it's not meant to replace a desktop application, but a processing way of looking at it for using shapefiles and similar data, processing them, and getting them into a format you're going to use. And the idea here is I'd like to make working with geographic data like working with other kinds of data in Python. So to use the tools that we use for other things in Python and have them work with geographic data. So we have to work with the desktop GIS systems and ArcGIS and QGIS and files that they can use. And with geospatial databases like PostGIS. We'd also like to make it easy to work with JavaScript tools that are on the web. But also the existing data stack within Python using NumPy and Pandas and other things. And in particular, how many people have used Pandas? So Pandas is a great tool for working with table-based data, right? So you get rows and columns and structured data and working with that as underneath their NumPy arrays. So GeoPandas is leveraging that and adding the ability to work with geospatial data, geographic data in Pandas. All right, so GeoPandas is a pure Python project. It works from Python 2.6 and up, and it depends on Pandas and some of the other open source tools in Python, Shapely, Fiona, PyProj. Some of these have compiled libraries underneath, and for plotting, Matplotlib, and Descartes does some of the helping stuff. And then there's some optional packages for doing other things. But GeoPandas is a pretty high-level look at being able to do things. All right. Things like geometry operations, data alignment, that is by index, coordinate transformations, map projections, that is, right? So to and from map projections, using existing file formats, and creating data structures from database tables. Anything can be output as GeoJSON. It can go straight to a web map. And it's got some built-in simple plotting capabilities, mostly for quick looks at data. Okay, so this is extending Pandas to do new things, and in particular, to do geography. So if you're familiar with Pandas, you know it deals with 1D data as series, data frames are 2D structures, and panels are 3D structures. So a data frame is the heart of what Pandas does. It's a table. It has rows and columns that are labeled, and it can do alignment on them. So GeoPandas has 1D geoseries objects that are geometry only, and it can act on this column of geometry, and 2D structures, which are geodata frames, that one column contains a special geometry column that it can act on. And there is no 3D structure yet, but there's no reason there couldn't be. It isn't much used in Pandas, really. It isn't that powerful. So Shapely does geometry operations. All of these things work in GeoPandas in a parallel way. This is some GeoPandas code. We can load a shapefile. This is a standard GIS format, and we've got it in a table format now. We set the index to a code that's one of the columns, and we can look at this as a table. We can see this looks like table data. We have a name for each borough of New York. We have an area. We have length. These are attributes on the file. And then we have a geometry column. And to plot that geometry is as simple as just call the plot method on this object. And it brings this up. And if you want to send it out to a file, you can just call a toFile method and send it to a new shapefile after you've done some processing, send it to GeoJSON, anything like that. We can do geometry operations here, compute the convex hull. Convex hull is just a computed property on the data frame, and it's the convex polygon containing each of the boroughs, and plot that. Other geometric operations, buffers, and so on. I got some examples. I can give you a link for some of these. I'm not going to spend time on that. But you can throw a result out to GeoJSON and immediately plot it in a live leaflet map if you want. So in the GeoJSON output goes straight to a leaflet web map. There's some geocoding capabilities built in. I should actually, we've got some spatial indexing and spatial joins are there now in the development version, but not in the release version. So there's a bunch of stuff we can already do, and we should release that soon. So I will, let's see. I'll end by just showing the GitHub page. This is where the latest and greatest version is. Just GeoPandas/GeoPandas, and that has more of these examples. All right, so thanks.
Anyone else? Announcements? Anything to say?
Question?
I have a question.
Oh, sorry.
Yeah.
Sorry. Brain's fried today. Apologize.
Is there, like, what sort of input formats does GeoPandas take? Like, just shapefiles, or does it take a variety of different things?
It uses Fiona for the input, so it can read anything that Fiona can read, which is many of the things that that Jordahl can read, the OGR inputs. Not everything, but many of them. So it can input. Well, GeoJSON certainly, a few other file formats.
Have you worked with GitHub's GeoJSON rendering?
Yeah, I mean, so not directly, but anything you have in GeoPandas, you could just spit out to GeoJSON, and if you upload it as a gist, it's there, right? So that's straightforward. There's no direct wiring up to it or anything. Yeah.
Do you support a variety of projections, and what's the default?
Yeah, so projection handling, every object in GeoPandas has a coordinate reference system attribute. So if you create your own, by default, there's no reference, and so it's just a naive flat geometry. But if you load it in from a shapefile, it'll automatically grab the projection from that. And then there's a method to project it to any other reference system that you want. So all you have to do is give it a PyProj string or dictionary of parameters to say, I want proj equals UTM, zone equals 13, and it will transform it to that projection. So projection transformations are built in to and from anything you want, and it's projection aware. Okay.
All right, now I'm ready for the day to be over. Sorry. Before we finish, anyone have any announcements? Jobs, anything? Stand up and go.
So I worked with Jonathan at NASA. My company does the security for the NASA contract. We're looking for Python or just developers in general.